All right, let's get right into it. I want you to imagine an AI that doesn't just follow a script. Picture an intelligence that can think in countless different directions all at once. Each one of those thoughts exploring, racing, and then coming back together. This isn't some far off sci fi idea, it's a real breakthrough happening right now called parallel reasoning.
Just let that question sink in for a second. We're so used to AI that works in a straight line, right? It follows one logical path from A to B. But what happens when you build a machine that can basically split its own brain, consider dozens of possibilities simultaneously, and reason its way to a conclusion? Well, it turns out that one question changes everything. And this really gets to the heart of the whole thing. On the one side, you've got your traditional AI. Think of it like a train on a single track. It's linear, it goes step by step, but here's the problem. If one step is wrong, the whole thing can just completely derail. But on the other side, you have parallel reasoning. This is all about being flexible, branching out. It's a lot more like how our own minds work. When you're trying to solve a tough problem, you don't just follow one path. You play out multiple scenarios, you debate them in your head, and then you pick the best one.
So let's dig into that problem a little more. The big limitation with so much of today's AI is exactly this. It's got a one-track mind. A single, tiny mistake early on in its process can cause the whole system to spiral, leading to an answer that's just flat out wrong. And that brittleness, that's the exact weakness these researchers set out to fix.
So how do you even begin to fix something like that? Well, instead of just making the models bigger or throwing more data at them, scientists tried something completely different. They asked this really fundamental question. What if an AI could split its brain? What if, instead of just guessing or calculating, it could actually reason?
And that led them to this idea of parallel reasoning. The core concept is just fascinating. The AI learns to literally pause in the middle of a thought. It just stops, opens up multiple independent lines of thinking to explore different possibilities, and then, here's the magic, it pulls all of those findings together into one single, much stronger answer. It's almost like having a little council of minds inside the machine, all arguing with each other until the truth wins out.
So what does this actually look like in practice? Okay, step 1. The AI is working on a problem, hits a tricky spot, and pauses. Step 2, it branches out, creating several parallel thought processes at once. Step 3, each one of those branches goes off and explores a totally different angle. And finally, step 4, it merges all that work back together to create one cohesive, well-thought-out solution. Sounds simple, right? Turns out teaching a machine to do this is brutally difficult. And boy, did they learn that the hard way. At first, the AI seemed to get the basic idea on simple problems. But the second they gave it harder data sets, the whole system just collapsed. The success rate dropped to almost 0. It was a total failure, but it taught them a crucial lesson. You have to crawl before you can run. The AI had to absolutely master the basics first. But here's where the story gets really interesting, because out of that failure, something incredible started to happen. Once they went back, trained it the right way, starting small and then scaling up, the AI didn't just get better. It actually started to evolve its own unique style of thinking. And the results? They were staggering. On some really complex math competition problems, this new system's performance shot up by almost 43%. Now, we're not talking about a tiny little bump here. That is a massive leap forward. But maybe the spookiest part of all this was how it got smarter. You see, the AI strategy changed all by itself. At first, it was just chaotic, branching out all over the place, but over time, it started saving its branches for the very end of a problem. It was acting like a careful student who double-checks their homework right before turning it in. And get this, nobody programmed it to do that. It discovered that cautious, effective strategy entirely on its own. And the surprises just kept coming. The researchers had these 2 versions they were testing. One was a stricter model, where every line of thought was totally isolated. The other was a looser one. Now, on paper, the strict one should have been smarter, right? Pure, independent thinking. But in reality, it failed miserably. It got obsessed with the easy problems and just couldn't handle the hard ones. It was the looser model, the one with fewer rules, that actually adapted better and got more answers right. It turns out sometimes giving an AI more freedom is what makes it stronger. They also ran into this fit-in trap with how they were rewarding the AI. See, when the only thing that mattered was getting the right answer, the AI got, well, lazy. It figured, why bother with all this complicated reasoning when a lucky guess might work just as well? It pretty much abandoned the smart new strategy
only using it about 13% of the time.
So they fixed it. They created a new, balanced reward system. Most of the points were for getting the answer right, sure, but some points were specifically for using the branching strategy well. The effect was immediate. The machine stabilized, it started using branching around 60% of the time, and its accuracy shot through the roof. It had finally learned that perfect balance between focused work and strategic thinking.
So let's zoom out. We've seen how this thing works, but what does it all mean? What are the huge, real-world implications of creating a machine that can actually reason? And this is why this is such a big deal. For years, the story of AI has been about more data, bigger computers, just more brute force. This is different. This is a breakthrough that comes from thinking smarter, not just bigger. It's a leap in intelligence strategy. And historically speaking, that's exactly how humans became the dominant intelligence on this planet. The potential here is just mind-blowing. Think about education with AI tutors that can actually understand a student's unique way of thinking. Or in healthcare, diagnostic tools that can explore every single possibility behind a patient's symptoms. This could completely change how we do scientific research, how we discover new things. The list just goes on and on.
Which brings us to the final and maybe most unsettling question of all. As these machines learn to reason, to strategize, and to adapt entirely on their own, what are we actually building here? Are we creating an incredible new partner that will help us solve humanity's biggest problems? Or are we taking the first steps towards creating a second form of intelligence on this planet? A potential successor? That's the question this breakthrough forces us to ask.